afternoon. This is Akanksha Shukla from Information Technology Department. Today I am going to discuss about the topic which is about neural networks, and this is a topic regarding the data analytics. Now, what are the neural networks and what they are called? Basically, the neural networks, we can also say that these are artificial neural networks or simulated neural networks and artificial neural networks, which I had already told. So, the ANNs or SNNs or neural networks are basically they reflect the behavior of a human brain. Okay. So, basically they train the computers, or these are the computer programs which are used to solve the problems regarding the artificial intelligence, regarding the field of artificial intelligence or machine learning, and also deep learning algorithms. Okay. Now, the ANNs or neural networks are basically comprised, or basically it contains, or it is a combination of the layers which consist of the node layers. In this, the layers contains the input layer, one or more hidden layers, and an output layer. So, basically the ANN are a composition, or basically they are comprised of the node layers. These layers can be of input layer, one or more hidden layer can also be present in artificial neural networks, and the last one is output layer. Each node or artificial neurons connects to another one. They have each nodes which are associated one with one another, each all have an associated weight and have threshold value. So, what is the basic concept here is used, that if the output of any individual node is above the specified threshold value, means if we have specified a threshold value for any neural network, then during the execution of that particular neural network, if the output of any individual node is going to above that particular specified threshold value, then that node will be activated and it can be able to send the data to the next layer of the network. Otherwise, no data will be passed to the next layer of the network. If and only if the output of the individual node is above that particular specified threshold value which you have defined earlier, then only that node will be activated and can be able to send the data to the next layer of the network. Here this is a diagram. In this diagram we can say that a blue color node represents the input layer. Okay. Here light blue color nodes represents the output layer, and these green nodes represents the multiple hidden layers. Means this one is showing the one hidden layer, this one is the second hidden layer, and this one is the third hidden layer. So, in this particular diagram there are multiple hidden layers. So, we can say that a neural network can be a combination of input layer, multiple hidden layers, or output layers. Now, basically the neural networks are rely, or they can based on the training data which are used to learn and which are used to improve the accuracy time to time. Now, whenever or however once these learning algorithms are fine tuned for accuracy, then they are powerful, they become the powerful tools in the computer science and artificial intelligence fields, and after that they can also be able to classify and cluster the data at a very high velocity. Okay. So, what is the basic concept here, that where basically the neural networks is based on the training data which is used, or which we use to classify the data, or which we use to train, which the training data which we have provided for learn or for improving the accuracy over the time. Then after learning over that particular training data, whenever the learning algorithms are fine tuned, means whenever these learning algorithms are appropriately convinced for the accuracy purpose, then these learning algorithms itself can become a powerful tool which we use in computer science and AI fields for classification and clustering the data at a very high velocity. Okay. Now, in the speech recognition or image recognition, what are the in the previous or in the traditional time, what we see that the task in performing the speech, or the task or the time which we are going to take in recognizing the speech or in recognizing the image can take the hours. Okay. whenever that task will be compared to this particular time slots or this particular current trend, then it will take a minute to solve that particular recognition problems, which are taking the 2 to 3 hours earlier in the earlier time. Okay, so one of the most basic advantage of using the neural networks or using these high trends technologies are that the things which takes the hours can be possible in the minutes also for their solution. One of the most well known neural network which we used or which we realized in our current trend is Google search algorithms. Okay, now basic working of neural network, how the neural networks work. First of all, here we can see that think of each individual node as its own linear regression model, means each individual node will be considered as a linear regression model which is composed of input data, weights, a bias or a threshold value. A bias is a value which can be added or which can be added also, which can be sum up also, which can be negotiate also based on the particular requirement. Okay, based on the requirement that whether you have to enhance the performance of the solution, okay, accuracy of the data. And the last one is an output. Sorry, the formula here we use is sigma Wixi plus bias value is equal to, here the sigma I is equal to 1 to m, means weights can be varied from 1 to m. So W1 x1, W2 x2, these are the weights and these are the input data and the weights. Okay, x1, x2, x3 are the input data. Okay, as we seen in the diagram that this is the input layer containing the input data. After that, what we assign? We assign each node have its associated weights plus bias value. So each input data contains a weight and overall the bias value. Now what we see here, that is the input, and based on these input, what we get the output function fx. Now if sigma w1 x1 plus bias value is greater than equal to 0, then the output will be 1. But if the sigma w1 or wixi plus bias value is less than 0, then the output will be 0. Okay, so based on these two conditions, the output can be varied from 1 to 0 or 0 to 1. Now once an input layer is determined, means whenever in the neural network you have identified that this particular layer is an input layer, then you have to assign the weights to the particular or the individual nodes of that particular input layer. Now the weights which each individual node is associated with, these weights helps in determining the importance of any given variable of that particular data set with the larger values, means the weights which are associated with the variables or with the input data can be helpful in identifying that which variable is contributing more significantly to the output or which is contributing less to the output. So these weights are basically helps in determining the importance of that particular variable, that which is more significantly important for generating the output and which is less significantly important for generating the output, or contributing more significantly or contributing less significantly to the output. Okay, so based on these weights we can identify this contribution in very proper manner. Now these all inputs are then multiplied by their respective weights and then we sum up all this data. Afterward, what we see that if the output is passed through an activation function which is used to determine the output, that activation function is used to determine the output. Now if that particular output exceeds a given threshold value, okay, then if that output exceeds a given threshold value, then only it fires or then only it will be able to activate the next node and then only the data will pass to the next layer in the network. Otherwise no data will be passed to the next layer of the network in the neural networks. Okay, so based on this concept, this results in the output of one node becoming the input of the next node. Means suppose this is a node, the output of this node is x, and if x is greater than the threshold value which I assumes that is y. So, if the output of that particular node is greater than threshold value y, then only that data will be passed to the next layer, or then only that data will be passed to the next layer of the network. So, for this particular node or for this particular layer, this input, what this input is? This input is the output of the first node of the layer. Okay. So, here it implies that the results of the output of one node become the input of the next node. Okay. Now, this process of passing data from one layer to the next layer, it defines this neural network as a feed forward network. Means here the output of one node becomes the input of another node. So, this change output of one node becomes the input of another node, and so on. So, this model implies that this particular neural network works as a feed forward network, but it can also work as a backward, it can also works in the backward propagation. Okay. Now, most of the deep neural networks are feed forward, means they can flow, or the data can flow in the forward direction or in the one direction only from input to output. But I had already said that you can also train your model, or you can also train your model based on the training data sets through the back propagation method also. Means they can, in this the data moves, the data can also be moved, can be able to move from output to the input. Means the data can also be moved in the opposite direction also. Means back propagation allows us to calculate and attribute the errors which are associated with each neuron, because it's in the back propagation what we say, or what we do through the back propagation neural networks, or through the implication of back propagation neural networks, we can calculate and we can estimate the errors which are associated with each neurons or with each node, individual nodes. So, with the use of back propagation method, we can also adjust and fit the parameters of the models appropriately, because through the backward method we can identify that at which point the error occurs and how can we adjust or how can we resolve that particular error. Okay. Now, we move on to the next part, that is types of neural networks. So, the neural networks can be classified into the different types. First one is the perceptron, which is one of the most oldest neural network and created by Frank Rosenblatt in 1958. In the perceptron, what we see that here only a single neuron is present, and it is one of the simplest form of a neural network. Means it basically, this is the oldest neural network. So, obviously it is one of the simplest form of neural network which contains only the single neuron. Okay. Now, the second one is feed forward neural networks. The feed forward neural networks can also be implied as a multi-layer perceptrons, and basically in this we can see that there are input layer, the hidden layers, or an output layer. Now, generally we say that the feed forward neural networks are also called as the multi-layer perceptrons. So, here we can have to notify one thing mainly, that these MLPs are actually comprised of the sigmoid neurons, not the perceptrons. Okay, because these perceptrons are basically used to solve the linear problems, but most real world problems are the non-linears. So, that's why here in the MLPs we use the sigmoid neurons in place of perceptrons. Okay. The data which we feed into these models, they are the foundations for the computer vision, natural language processing, and other neural networks. Okay. Now, the third one is convolutional neural networks, means CNN. These are also similar to the feed forward neural networks, but what is the basic difference between these two are, the convolutional neural networks are basically utilized for the image recognition or for the pattern recognition or for the computer vision. Means basically when we have to recognize the images, or when we have to recognize the patterns, just like fingerprint recognition, biometrics. So, if you have to recognize the image, so in these applications where we have to recognize somehow patterns or somehow the images, then basically we use the convolutional neural networks. Okay. in the convolutional neural networks, what we see that generally what we do, we convert the images or the patterns into the matrix form, and after that we apply the calculations and many more matrix calculation performs. We have to perform many calculations over that to identify the patterns within an image only. Okay. Now last one is recurrent neural networks. These are also identified by their feedback loops, and basically these learning algorithms are primarily used for time series data. As I had already told in my previous lectures that what are the time series data? The data which is based on, or which we observed, or which we record on the basis of variations, time variations, just like if we record or if we observe the data monthly, yearly, quarterly, daily basis. So then we observe the data in this type of time scale methods, then that particular data comes under the time series data, which we use to make the predictions about the future outcomes, just like in the sales forecasting, stock market predictions, and just like in measuring the temperature, heart rate monitoring, weather forecasting. So these are the some applications these are some data for related to the time series data, okay, in which we do the data analysis for the prediction purposes or for future outcomes, to identify the future outcomes. Now what is the learning inside the neural networks? So the principal reason why neural networks have attracted so much in this current trend is the existence of the learning algorithms which we use in the neural networks. So that algorithms uses the data which is basically estimates the optimal weights in the network, and that can be able to perform some task for which they are assigned. There are three basic approaches to learning in the neural networks. First one is supervised learning. So in supervised learning, what we do, we use a training set basically, and that training set consists of pattern pairs. In this pattern pairs, we have a input pattern, and based on that input layer, we have a corresponding desired or corresponding target output pattern. Now that particular desired output can be regarded as a network teacher for that particular input, and the basic approach which we use in supervised learning for the network is to compute the output particularly and its current weights which produced for that particular given input, and after that what we do, we compare this network output with the desired output. Means suppose if you take an example that our goal is to assign, or our goal is to assign the task to the 5 students. Okay, so what is our goal, or what is the desired output is assigning the task to the 5 students. But initially what we do, we are not be able to assign the task to the 5 students. We are only capable to assign the task to the 2 students. So that difference, basically that comparison is compared using the supervised learning methods, or basically in this supervised learning method, what we do, we have to check the networks, and basically we train that model which is capable to compute the output associated with its current weight, and then produces a given input, and after that we compare that particular given output and with the desired output. So the aim of this learning algorithm is to adjust the weight so that we have to minimize the difference between that network output and the desired output. Means in the supervised learning, what we do, just like I have taken an example that we are not be able to assign the task to the 5 students. So that particular gap between 2 and 5, that our goal is to assign the task to the 5 students, but we are not be able to assign the task to the 5 students. In spite of that, we had assigned the task to only 2 students. So that gap between 2 and 5 can be minimized using these type of learning algorithms. Next one is reinforcement learning. Basically in reinforcement learning, it uses much less supervision. Means here the data is not so much supervised and not so much trained. So if the network have to perform any task, then the reinforcement signal is a simple yes or no signal which is indicated at the end of that particular task, and it indicates only that the task has been performed satisfactorily or not. So in reinforcement learning, we don't have so much of supervision, and the most best example for reinforcement learning is self-driving cars. Next one is unsupervised learning. In unsupervised learning, no training data sets are available, no training signals are available. As we see in the previous two approaches, there are training data sets are available, labeled data sets are available, but in unsupervised learning, no labeled training data sets are available. So the aim of unsupervised learning is to make sense of some data sets, just like on the basis of their characteristics. Just like in the example here, the example for unsupervised learning is clustering. So in clustering, what we do, we suppose we have 4 data sets, or we have 4 data, okay, 3 stars and 1 circle, and you have to form a cluster. Okay, so in unsupervised learning, according to the unsupervised learning, here nothing is provided, or no training signals or no training data sets are available, only the symbols are available. Now we have to identify based on that appearance of that particular symbols, that these three are these three images are resembling somehow similar. So what we do, we put these 3 stars into one cluster. Okay, and this circle is becomes an outlier. Okay, so based on the characteristics, or based on the recognition of that particular data sets in unsupervised learning, we make sense of that particular data set, but no training signals or no label data are provided in unsupervised learning. Okay, so that's all for today's lecture. Thank you.